Hey everybody, this is Russ King, and just want to do a little demonstration video on how to draw a basement style HVAC system. So what we have here is basically a single-story house with a basement that's pretty much the same footprint as the conditioned floor area. It doesn't really matter. The point is that we're going to put a duct system underneath here that will handle this house. The first thing you're going to have to do is place an air handler in the house, and typically a basement system like this is going to have an upflow unit down in the basement. So somewhere down here in the basement there'll be an upflow unit. So the best way to do that, to keep things kind of clean, I'm going to turn off the first floor, the main part of the house, go over here and just turn everything off so we just see the basement. Turn off the grid. Okay, so there's our basement, and so we go here to HVAC draw, we go to air handlers, and we place an air handler here, and it's already designated as an upflow. If it was horizontal when you started, it would look something like that. You can do downflow, upflow, or horizontal, so we'll do an upflow. There's a button here to move it vertically, and you'll see this green handle shows up there. So you basically just drop it down. I drew this basement with 8-foot height to it. Okay, and so we're going to have to adjust some of the parts of the furnace / air handler in order to get it to fit in there. So I'll just do that real quick. Okay, so we got 24, 30, 18, and 24. Whatever your height is that you have to work with, that's what it is. But the point is you can change those. You can also change the cross-sectional area as well if that 24 by 24 is too big for the cross-sectional area. Okay, so the way I'm going to do this is I'm going to put a rectangular supply trunk that runs down this way, and another one that runs down this way, and then I'm going to hit all the registers. So once you have the air handler in place, you can run your load calcs and size your equipment, get your airflows and all that good stuff. Okay, and then once you have all your airflows and stuff, you'll come back and calculate your friction rates and things like that. But I'm just going to show you how to draw your system and the process you would go through to size your system once it's drawn. Okay, so you come over here and you'll see one of the choices is rigid rectangular duct, and then you have these new fitting types choices here, and there's a whole bunch of choices here. Whenever you insert a new duct, you have to tell it what kind of fitting is going to be on the end of that duct. It can't be just a duct, it has to be a start and a finish. And so what I'm going to do over here is I'm going to run a duct out both directions off the supply plenum, and it's going to have an end cap on it. So I'm going to choose end cap. Okay, and then to come off of a plenum like this, we need a start collar. So it defaults to a round start collar, but you can click on it and change that to a rectangular start collar, and it's going to be 24 wide and 12 high is the duct that I'm going to run down this way. Okay, and so once you select that, go back to rigid rectangular, select it, and just hit enter, and then it draws a duct. Now you notice it has a transition on here. Okay, well this first transition is going to be the same size as the start collar. It's going to be 24 by 12, so we don't really need that. So if we click on that, we can change that to let's see, 24 here. So there we go. So it's a 24 coming off there. Now sometimes I've seen where this duct comes off and it goes up into the floor joist or something like that. So that's what these offsets are. So if you want to offset it by 6 inches, you can shoot it up like that. You can change the length of this transition, so that would be down here, transition length, if you only want it to be 6 inches. So you see there it's smaller. Okay, but I'm just going to have these come straight off like so. Okay, and then there's two ways to extend this duct. You can type in the length of the duct down here. It's currently at 3. I could type in 20 if I wanted to, and it would go out 20 feet. but the easier way is to grab the fitting that's on the end. So click on fitting and you'll see this handle down here. The fitting that's on the end is the end cap. So I'm just going to grab this fitting and I'm just going to drag it out as far as it needs to be. Okay. So we'll go all the way to the end. We can come back and adjust that later. So that's a 12 by 24 coming out this way. We'll do the same thing on this side. So start collar, Alt, click, highlight it, click rectangular, tell it what dimensions you want to be. You can drag it up and down like so. Okay, go to rigid rectangular duct, click on the start collar. We've got the end cap selected, hit enter, change this to 24, and then click on fittings and just drag it out as far as you need to go. Okay, so we have the start of our duct system there. Okay, so the next thing to do, maybe even before this actually, is to put in the registers. We don't know where the registers are going to be. I just know that I'm going to need this big duct transition, or this big duct supply plenum / trunk going down the length of this house like so. So let's turn on the first floor plan so we can see where the rooms are. We go to registers, we hit place on floor, so that's going to do floor registers for us, and then Alt click will place the registers. They default to 12 by 6. The size doesn't affect anything in the calculations, it's just a visual thing. And then if you want to turn it, you just hit the tab button and that rotates it. Okay, so I'm going to go ahead and put these oh, and by the way, if you want to move these registers, you have to turn on the floors. That's to prevent you from accidentally moving something. So I'm going to turn on the floors to the second room. I'm going to lighten the rooms so you can barely see them, and now I can move those registers around. Okay, okay. Alright, so we got all our registers. I think that's all of them. We could put one in the entry if we wanted to. But actually in this, I have the entry and the dining room lumped together, grouped together as a single load. So whatever load is on the entry room is going into the dining room. Okay, so there's our registers in relation to our supply trunks. And now the next thing to do is to run some ducts out to each one of these. So what I'm going to do is I'm going to turn on the grid here to just kind of help me line things up, and you can see these lines here just sort of give you reference points to the registers. So the way I'm going to do this is I'm just going to put a round sheet metal duct with a hard elbow coming off the top of this plenum and just coming down straight into these registers. Now it's going to hit the registers from the side. So the other thing I need to do before I do that is you'll notice that these registers are bottom entry, straight run, straight into the bottom of those. So we need to change that. So in register mode, you click on the register and you'll see down here it says side and top in the bottom left corner. So you change that and it puts a side entry register like so. Now if we hit tab to turn it towards the direction we need it to go, what we need to do is change the dimension. Instead of 12 by 6, it needs to be 6 by 12. Okay, so there's the side entry. Okay, so I'm just going to go ahead and do that to all of these. Get it pointing in the right direction. Okay, so I got all the register boots pointed in the right direction so that I can just run the ducts off here and go straight into those. Alright, the next thing I'm going to do is I'm just going to put start collars along the top of this supply trunk, lining up with each one of those. Now you notice this duct and this duct are in direct line with each other, and that's probably not going to work. So I think I'm going to move this one over just a tad. It doesn't matter which one you move. The point is that you're going to need to run two parallel ducts alongside each other. So I'm just going to move these in just a little bit. They probably want to have those be symmetrical in the room. Okay, so those look good. That one. Okay, so let's do the back side of the house first. So I'm going to go to Start Collars, and I'm going to put my default size as a 6-inch, either 6-inch square or 6-inch diameter, just so they're not so busy. So Alt, place, Alt, place. Let's look at the front now. So this guy, that one lines up with the top of the plenum. We probably don't want a duct coming off here. So a couple things we can do. We can either slide the air handler to the left or the right, or we can slide the register to the left or right. And because it's easier, I'm going to slide the register over. Okay, so all of those, and you notice I put them on one side or the other. So if they're in the back of the house, they're on this side. If they're in the front of the house, they're more towards the front. That just kind of helps me see which direction it's going to go. Alright, the next thing to do is we're going to put little elbows, little hard elbows coming off the top of here. So we're going to go to Rigid Round, and we're going to select as our fitting type a hard elbow. Now this is going to look kind of funny, but this is kind of the best way we figured out how to do this. So you're going to click on that, and you're going to hit Enter, and you'll see this little periscope looking thing pops up. You just hit Tab until it points the direction you want. Okay, so I'm just going to do that on all of these. Okay, now we come back, we hit Fittings, and when you click Fittings, you can grab the fitting and move it around. So you kind of want to be down at a lower angle than I am, and just pull them down like so. Okay, so now we have the hard elbow coming off, and we've got the supply plenum. Here's the cool part. You click on Rigid Round Duct, you select one end, select the other end, and hit Enter, and look what it does. Connects those two. Okay, and I have it set as default 6 inches, so that's why it's that size. These are big. They default to big basically to make them easier to click onto. So they look funny at first, but once you attach the ducts, they look a lot better. Okay, so there we go. Now we've got them all coming off there. The next thing to do is to do the returns. And a lot of different ways to do returns, but in this particular house, there's a place for the return, and I'll show you what that is. I'll turn on the floor plan, and you'll notice that the furnace is right below. If I look straight down from the top, the furnace is just off to the side of this thing that says linen storage right here. So what it is, it's a cabinet in this hallway, and in the bottom face of this cabinet is going to be the return grill in this hallway. So you see my furnace is off just a little bit. So there's a couple ways I can do that. I can slide the furnace over if that's doable in real life, or I can just have my sheet metal come off and make that transition to come up, because I'm going to come up through the bottom right here and put my return in the face on this side here. So let's see which one works. So I see it needs to go up 1, 2, 3, and over about 2, or just slide this over about 2 feet. So let's see what that does. So I click on air handler. If I click on it, it highlights, and I can drag the whole thing like that. But you notice what it does is it pulls all the ducts with it. But that's not a horrible thing. You can certainly fix that. So let's fix it real quick. So the way to move a connection like that, so I click on fittings, I grab the handle and just slide it over. And then to move these individual ducts like that, what I do is I click on Start Collars, and if I click on it, it'll jump right back on there. But all these other ones, I need to slide them over, and I can use the grid lines to get them lined back up. So that's probably the easier way to do it. So the moral of that story is to make sure your furnace is in the right place before you place all your ducts. So obviously the assumption is that this big supply trunk is running underneath the floor joist, and then these ducts are jumping up into the floor joist and running towards the front and the back of the house. Okay, so hopefully I got that furnace lined up good. I should have checked it before I fixed everything, but live and learn. Okay, so we got the furnace lined up under the floor plan of the second floor, and what we're going to do is we're going to have a return come off the bottom of the furnace, come over, and then come up into the bottom of this linen cabinet here, so that's where the return grill will be in the hallway. Alright, so let's draw that. So the duct's going to come off of here, off the bottom, come off the bottom, and then go up through the floor and penetrate up into the floor, and there'll be right above this thing here, it'll come up, and so if you're walking down this hallway here, there'll be a return grill right in that face there. So let's draw that. So the best way to do that is with a series of rectangular rigid ducts. So I click on that, I make sure that end cap is chosen, okay, and then I'm going to set the default dimensions to 24 by 24 because that's what everything's going to be. And then I'm going to put a start collar right here, click on it, tell them it's rectangular, then I click on rigid rectangular, highlight the start collar, hit enter, and it comes out about yay many feet. Okay, the next thing is let's put another start collar on the top, start collar there, highlight rectangular, rigid rectangular, highlight, enter, and then it comes up. Okay, now if we click on fittings, grab that end cap that's on the end of here and just drag it up through the floor to the second floor like so. Okay, now that return is going to be right in the face there, and we have this thing called direct supply and return, and that's when you're putting a supply and return right in the face of a duct, usually a rectangular duct. Okay, I'm going to highlight that, alt click, and it's a little guy. If I highlight it, now I can specify the height and the width and all that good stuff. So this is going to be a big dude. Now I'm going to make this as big as I can. I'm going to call it 30. Okay, so it's going to come up out of the floor 30 inches. It's going to be the whole bottom of that cabinet down there. That might be a little optimistic on that, but you do what you can do. So go back to fittings, grab it, pull it up so that's all the way through the floor like so. I can highlight that return, pull it up as high as I need to, put it anywhere I need to go. So you got the basic idea. It doesn't have to be perfect for this. We're just designing a rough design, sizing the ducts. The nitty-gritty details will happen in the field as is typical, but this at least gets you pretty darn close. Okay, alright, so there we go. That's return, supplies. Let's look at it from the front. That looks pretty good. Now the sizes of all these are going to change when you do your load calcs and all that good stuff. Okay. Okay, so once you do your load calcs and select all your equipment, which is all covered in a different video besides this one, the next thing to do is then you come into your duct table and you calculate all your friction rates. Okay, so we specified in the manual S portion that we have 1200 CFM at 0.6 inch static pressure, and now we have to put in our various losses, so you're gonna have to look these up. But I'll just throw some numbers in there that are fairly typical. But you should actually look these up to see what they're actually going to be. Okay, so that's all our static pressure. So we started with 0.6. We have all these fittings and accessories and the coil and everything that takes away from that 0.6. We're left with 0.41. We come here, we have our external static pressure minus our component static losses, 0.6 minus 0.41. We're left with 0.19 is our available static pressure. Now the next thing to do is to figure out the total effective lengths. So we click on the TEL table, we come in here, and the software does a good first best guess at the fittings as you've drawn it. So it knows there's a register boot, it knows that there's a hard elbow, it knows that there's a length of duct. There are some things it doesn't know, so you're going to need to click on each run, like so. And it's this guy here. So this first one is supply 1. That's that register there, and you see it, the air goes through this duct and out this trunk here. So we got to start here, we got to calculate using the manual D, total equivalent lengths, appendices. We calculate whatever the loss of this is, whatever the loss of this is, and so on and so forth. Okay, so you just go through and you add these all up. So I don't have time to do that in this demonstration video, so what I'm going to do is I'm just going to go in and I'm going to throw in a bunch of extra lengths here. All of these numbers are editable, so I'm just going to come in and put 50 in each one of these for unforeseen totally equivalent lengths. In an actual project, you're going to want to be more precise with that, as is necessary. And let's throw some here in the return as well. Let's put a bunch in there. Okay, so we have a whole bunch of equivalent lengths. We have not a whole lot of static pressure left. And if we come up here and look at our friction rates that are calculated, 0.09, 0.09, 0.07, those are all reasonable. If they get below 0.06, you want to be a little concerned. You may want to pick a different furnace that has a higher available static pressure, things like that. Okay, but this is just an example, and you can kind of see the process of how the thought process that goes into this. Okay, so we got all our friction rates. Let's go back to the data table, to the duct table, which is where this is. It shows all our friction rates right here, and we hit the magic auto size ducts. Now watch what happens to these numbers up here when you've got this many CFM here with this friction rate here, and it's going to size these ducts for us. So auto size ducts. A little window pops up warning you that rectangular duct auto sizing is not implemented yet. Rectangular ducts must be sized manually. So we have not programmed into the software the ability to downsize these ducts. There's just too many personal preferences. There's too many situations where you're driven by the available size of duct that you can purchase, and so on and so forth. So we're going to, for now, this is going to be a manual option, and I'll show you how to do that in just a minute. Okay, so you'll notice that some of these change. Some of them are 6s, now some are, we started off they were all 6s, and now some are 6s, some are 8s, and some are 7s. So this is the diameter of these ducts running out here. If you want to see which one is which, just click on it. So that's a 6-inch there, 6-inch, 8-inch, 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 8, 7, and so on. Okay, we've got some rectangular ducts here, and The way the software works right now is that technically there's a very, very small duct coming out of here. So do notice this note up here. It says ducts serving any fitting are treated as trunks to allow different duct types on either side of the fitting. So what we had to do was we called this little section right here a trunk so that it could be treated differently in case for some reason you wanted this section here to be rectangular coming up into this fitting and then round coming out. If we called this one duct, you would not be able to use different sized ducts, or different types of ducts I should say. So you may want sheet metal coming in and flex coming out, and the only way to do that was to call this a trunk and this a branch, even though technically that's not the definition of a trunk and branch, but that's how it's treated over here. So this is this little trunk right here. SB1 is served by ST2. SB1 is served by ST3. ST3, if you click on it, you can't really see it. Let me show you how to find it. If you go back to HVAC draw, fittings, click on this and raise it up. Data, ST3, there it is. It's that little guy there. So the reason we treat these separate is just so you can make that a different kind of duct from this one if you needed to. That was the best way we figured out how to handle this. Okay. Okay, so back to the duct table. So as far as the rectangular sheet metal ducts go, what you can do is you can then break these into sections. So you can figure out how much air is passing through this. Say, let's put a reducer here. You can figure out how much air is passing through here. You can figure out how much air is passing through here, and you can figure out how much air is passing through here. And you can put reducers there if you want to. So let me show you real quick how to do that. Use the Alt click key, and it puts this little slice through there. Okay, so you choose end cap reducer right there, and you hit enter. Okay, so you can see it inserted this it looks like a fitting here. It's just a reducer. At this point it looks like a splice because these two ducts are the same size. But if I come in here and I click on rigid rectangular, it highlights that duct, and then I can change the size. I can change the dimension of the part that's attached here. I can change the length of this fitting, and I can also change the dimension of this flex duct down here. So down here at duct, it's 24 by 12. If I change that to 18, you can see it put a little reducer in there, and it reduces it down the center by default. But if I wanted to scoot it to one side or the other, I can do it down here like so, and you see that lines it up. I just shifted it back 3 inches because the difference is 6, so I shifted it back 3 inches, and so the back is lined up. Okay, now as far as the size goes, 18 by 12, you'd have to look and see. So you go into data, go into ducts, and then you find that duct by clicking on it. So it's this guy here, 18 by 12. So it's 273 CFM at 0.06. So you can use a good ductulator with a round to equivalent converter and calculate to see if that's correct or not. Okay, so now if I want to actually come in and actually size these rectangular ducts, I'll kind of show you the process that I'll do. Is you can look at each point and see whether how much air is going through and whether the duct can be downsized or not by going into the data table, the duct table, and then just clicking on different sections of the rectangular sheet metal duct. So this one here has 712 CFM, so I'll go in. It's currently at 12 by 24 dimensions. I'll go in, I'll put the 0.08 friction rate right on the 712 CFM number, and then I'll look at the rectangular to round transition. Again, it's kind of personal preference, and what kind of materials you have available as to how many reductions. So I'll just kind of do that real quick and show you how it's done.